Howdy!
My name is Ethan Andrews.
My name is Jonathan Bowie.
My name is Ned Figueroa.
And we have chosen for our project the quad pendulum. We took the inspiration from the double pendulum and we wanted to add an extra layer of complications, so we added two more bodies with free range of motion, and we are going to test its movement on different simulations and experiments.
Provided in the slideshow for our project proposal is our Google Drive link alongside the YouTube video for this video specifically that we are recording for you right now. Okay, regarding the pendulum itself, the idea for each rod for the quad pendulum is that they are essentially weightless. Not exactly weightless, because it's going to be quite impossible to do something like that, but the weight of the rod itself will be lesser, far lesser than the tip mass or the endpoint mass of each rod. Additionally, each rod of the pendulum is stacked on top of one another, so it's stacked in a, like the idealistic stair-step framework, where it's 1, 1, 1, 1. And bearings and screws will be imported at the end of each to not only add mass, but add a rotation feature for each rod and connect them with the screws as well. And it will permit a proper rotation on top of the addition to mass. Each rod should be able to fully rotate, ideally, despite their connection to one another. There's a spacer between each rod as well. Attached to the slideshow for the proposal is an idea for a 3D CAD model design that Jonathan whipped up for the quad pendulum, although the design is subject to change and has already changed itself currently.
And so when I designed this, I initially went with just 4 rectangles of the same length, and they all had holes that would fit a bearing of 22 millimeter width, so the hole had a press fit interference of 22.1 millimeters when I printed it. I've since redesigned and reprinted it with a large hole in the middle of the pendulum pieces itself to allow even more weightlessness of factor. And on top of this, I've changed the lengths of each individual component of the pendulum so that they will not knock into the nuts and bolts that are holding the pendulum itself together, but also so that the smaller pieces and the larger pieces have a larger contradiction to have a more sporadic kind of motion between them. I'm looking at designing a third and final model, which will have rounded edges and just kind of look a little bit more professional, but that is it's all subject to change.
We have the project description of the frame, which is holding up the pendulum, as you can see. They went through multiple design changes, primarily, and first it was a sheet of plywood held up by struts on each of the 4 sides and corners, but then it went through a redesign so that it would be better for project and simplicity when buying supplies, and so we used simply 2x4s creating a frame. A third design came in to create a more stable design with 2 struts on the right so that it could swing freely on the front and would be much stabler when the pendulum was swinging sporadically back and forth, allowing for a much more easier system reading.
And on top of this, over the plywood, we plan on draping either some kind of canvas or sheet that will cover the wood and allow the pendulum to swing on a clear background that we can easily track its motion on later on down the line.
For the plan of execution, there's an idealistic modeling phase, a simulation phase, mechanical and electric computer application for the entire project itself. For modeling, we will have the CAD model as kind of the design concept at least shown earlier and furthered along the lines as we come to the final end of this project, alongside the block diagram of the quad pendulum, which will be based off the lab project for the simple pendulum, but just kind of added to add for the other 3 rods to that idea. Additionally, for the simulation, we will simulate the components and parameters of each rod and specifically the overall quad pendulum itself. That is in regard to displacement and in regard to the angular velocity. Each point of the rod will need a separate simulation, or at least a separate observation of output, because since its length is kind of 4 times the amount of a simple pendulum, each rod specifically has their own velocity, their own displacement, as each one experiences a more sporadic motion and or movement separate from one another. And we'll have to determine the outputs. Yeah.
And are you planning on doing that through measuring the revolute joints or the mapping of the angles between the two?
We'll have to map the angles between the two. If anything, we can try and figure out a way to track the angular motion visually by camera, or we'll have to see what we can manage based off of time and what we can do with visually tracking it.
And so on the mechanical side, like I said earlier, I'd already 3D printed one design. I plan on 3D printing one more design using that same press fit model of 22.1 millimeter to fit the bearings. I'm going to secure the bearings in with some form of glue and construct the pendulum itself through a series of 5/16 inch nuts and bolts and washers to allow the pendulum to swing freely within itself, to allow the pendulum to fully swing and not interact with other components of the pendulum. After that, the frame for the pendulum will be constructed out of the pieces of plywood we spoke about earlier, and the sheet will be draped over in order to make it more professional looking. We will have a singular screw drilled in the middle of the pendulum with the clearance of 4 feet around each part of the circle, and the pendulum will be secured onto that screw, and it will be tested. We'll probably do several different types of tests. We'll try dropping it freely from the top. We'll try swinging it from the left-hand side. We'll see what produces the most sporadic motion, and from there we can choose that motion path as the origin point of our simulation. For the electrical and computer side, although our system is entirely mechanical, as far as utilizing electrical and computer components, we are going to record the pendulum's motion and track its movements with color-coordinated dots on each of the bearings and revolution joints that would be within the simulation. And that motion, we're planning on plotting it beside the simulated motion of the pendulum. For the work distributed, this is a very large group effort. We are all heavily in communication with each other about every single part that we get done, every part that we do. The report is going to be worked on by all three of us, and that will be done in collusion together. As far as single assignments go per se, Nathan has taken on one portion of calculating the equations for the system and helping Ethan with the Simulink creation of the simulation. For Ethan, he is doing the Simulink creation with Nathan, and he is helping me construct the base and the model itself. I took on the construction of the model and the design of the model, as well as helping Nathan calculate the equations for the system.
For the timeline, we are spreading it out by design, construction, and testing phases. So we have the design of both the 3D model, the construction framework, and the Simulink model itself, all due by the current day, which is June 24th, 2025. And then now we're leading into the construction phase of this whole project, building the pendulum, which is already mostly constructed unless we are to do a design change, start building the frame with all the woodwork, and then further model the quad pendulum on Simulink and begin testing. Additionally, we have the execution and testing phase towards the end of this week. So the construction phase is idealistic to be done by Thursday, Friday, Saturday, and at the end of that date, we'll begin the testing phase where we're just going to test and track the pendulum's motion, record it, and then compare it and do a parameter estimation between the physical model and the simulated model.
And on the timeline, as you can see, the green dots represent our so-called due dates of when we want our portions finished by, and the yellow dots represent when we started them, when we plan on starting them, and these are all open to changing.
The outcomes that we expect from this project, there are three main ones. The first is to get sporadic motion from the pendulum, as there are 4 different arms working on the same pendulum end over end. The angular position and velocity we want to be able to track with a target-seeking application in some sort of camera. Be able to take that data, put it into an Excel file or .csv file, put it into parameter estimation with Simulink or some kind of modeling program, and model that sporadic motion in a simulated model as well.
Thank you very much. We look forward to presenting this down the line.